With the ever-changing world that we live in, it is important to advance, innovate, and bring new ideas. Hey, my name is Smangele, and allow me to lay out some of the new techniques for water treatment. In this video, we'll be taking a deeper look at advanced oxidation process, micro and nanobubble technology, electrocoagulation, and reverse osmosis. As mentioned, one of the new techniques for water treatment is the advanced oxidation process, which is a process for the generation of hydroxyl radicals to remove pharmaceuticals from water. The process includes ozone, it includes the UV light, it includes hydrogen peroxide and various combinations, which are used to destroy organic contaminants as the water flows into the treatment tank. This process also involves the formation of strong oxidants like the hydroxyl radicals and the reaction of the oxidants with the organic contaminants in water. In the advanced oxidation process, we have the ozone step, which occurs in an alkaline solution where the hydrogen-containing compound interacts with ozone to decompose and to reduce the hydroxyl radicals. The ozone can be used on its own at a higher pH level due to the abundance of hydroxide ions. We also have the hydrogen peroxide step, where the hydrogen peroxide reacts with compounds containing hydrogen and oxygen in a less complicated manner. In the UV step, the ultraviolet light is used to break bonds quickly and easily, and it has the ability to prevent reproductions of pathogens in water. It is used as a disinfectant and not as an oxidant due to its wavelength. The combinations are also included because they are the factors that must be considered when selecting the best process for a specific application. These combinations include composition of water, treatment objectives, UV exposure, dose of chemicals, the consumption of energy, and the cost. Like any other technique, the advanced oxidation process has its disadvantages and advantages. And the advantages of this process is that it has rapid reaction rates, it has the potential to reduce toxicity of organic compounds, and its disadvantages are that it is able to quench some of the excess peroxide that is required for some applications, and it is also expensive, which means it requires a lot and a large amount of investment. Micro and nanobubble technology is amongst the new techniques that are used in water treatment, and it is used to detoxify contaminated water by catalyzing the reactions of chemicals and improving the efficiency of the treatment process. This technique is applied in wastewater and water treatment. It is applied in microbial growth and product enhancement. It is also applied in chemical and pollutant biodegeneration, also applied in biological substance harvesting and extraction. It is applied in drug delivery and in dentistry. It is also applied in pathogen removal. Other applications of this technique include flotation, disinfection, aeration, and advanced processes whereby bubbles are generated from air and nitrogen to enhance the activities of microorganisms or bacteria with or without oxygen on the solid surfaces and the membranes. The advantages of micro and nanobubbles technology is that it is less chemically consuming and it is environmentally friendly, and its disadvantages are that it has high energy costs and it releases an abundant amount of waste. Electrocoagulation is a third technique that we take a look at amongst the new techniques of water treatment, and it is used for wastewater treatment, wash water treatment, industrially processed water, and medical treatments. It has rapidly grown due to its ability to remove contaminants that are generally more difficult to remove by filtration or chemical treatment systems, such as emulsified oils, petroleums, refractory organics, suspended solids, and heavy metals. The electrocoagulation technique works in such a way that as the wastewater contaminants such as suspended solids, heavy metals, and emulsified oils and greases pass by the electroplus plates, which are energized by the DC electrical current, they are able to accept a positive and negative charge, which causes the tiny particles to bond together like magnets. Then the contaminants that are then automatically removed from the clear face of water are then transferred to a sludge dewatering system for easy management. Electrocoagulation has its disadvantages and advantages, and the advantages of this process is that it has a better effluent, meaning that there are no dangerous chemicals, toxins, and odors that are left behind. The metals can be recovered from the solution and it uses less electricity. The disadvantage of this process is that the electrodes that are used are impermanent. There is active fine tuning that is required, and there are many factors that can affect the results, and these factors include the pH, the density, the polarity, the particle size, the design of the electrode, and the gap between the electrodes. The last technique that we take a look at is reverse osmosis. This technique is used for the removal of molecules and ions present in a solution through creating a pressure gradient between the solution and the semi-permeable membrane. One of the most prominent applications of reverse osmosis lies in residential, urban, and commercial water filtration systems, whereby seawater is desalinated. The method not only reduces the quantity of salt in the water, but it also effectively filters out pathogens, unwanted bacteria, toxic materials like arsenic and other metals, as well as inorganic and organic contaminants. Reverse osmosis also helps in purifying specific liquid that contains an undesired amount of water. All these new techniques are very important and play a vital role in giving the best quality of water and the best water treatment. And we have come to the end of the video. Please don't forget to like, leave a comment, and share the video with your family and friends.